Hello guys, this is the second part of our solution to the JAMB past paper questions on the topic of indices. And the first question that we have for today is solve for x in 8x to the power of negative 2 equals 2 divided by 25. Let's write out the question. So 8x to the power of negative minus 2 equals 2 divided by 25. Now the first thing that you should do in this question is that you change this x to the power of negative 2 so that this negative sign goes away. So how do you do that? Well, you can do that by writing 8 divided by x squared. If you remember, this is one of the rules that we've explained in the previous sessions. So 8 divided by x squared equals 2 divided by 25. Now the next step is cross multiply, because if you cross multiply you can simplify the question, the solution here. So x squared, right, times 2 equals 8 times 25. Now since we are looking for x, we need to eliminate this 2. How do we do that? We can do that by dividing both sides by 2. So dividing both sides by 2, you get x squared, this 2 will cancel, and 2 goes into 8 4 times. So x squared equals 4 times 25. Now the next thing that you should do is, since you have a square, if you want to eliminate this square, you take the square root of both sides of the equation. And the very general principle that you need to recall at all times is that whenever you perform an operation on the left hand side of the equation, you must as well do the same for the right hand side of the equation. So the square root of x squared equals x. Now the square root of 4 times 25. Here you can, 4 is a perfect square, 25 is also a perfect square, meaning that 4 is a number that is the solution of two numbers that are multiplied by themselves. Same thing goes for 5. So if you multiply 5 2 times, it gives you 25. So you can take individual square roots. So for example, this expression is the same as the square root of 4 multiplied by the square root of 25. And this is the very first rule of surds or radicals. And we've discussed this in the radicals topic, the rules of surds. So the square root of 4 is 2 and the square root of 25 is 5, which eventually equals 5 times 2, which is 10. So x equals 10. This can also be seen as the square root of 4 times 25. 4 times 25 equals the square root of 100, and the square root of 100 is 10. Find the value of x if 1 divided by 64 to the power of x plus 2 equals 4 to the power of x minus 3 divided by 16x. As usual, we would write the question. So 1 divided by 64 to the power of x plus 2, right, equals 4 to the power of x minus 3 divided by 16 to the power of x. Now looking at this question, we can express 16 and 64 in terms of 4. So in the exponents of 4. So 1 divided by 64 is the same as 4 cubed, which equals 4 times 4 times 4. That is 64. So 4 cubed to the power of, right, bracket x plus 2 equals 4 to the power of x minus 3 divided by 16 is the same as 4 squared. 4 times 4 gives 16. And here we had 64. So 4 squared to the power of x. Yeah, so 4 to the power of 2x. Now, you can open the brackets. 1 divided by 4 to the power of 3 times x is 3x plus 3 times 2 is 6 plus 6 equals 4 to the power of x minus 3 divided by 4 to the power of 2x. Now here you can apply the rules of indices. You can also, at the same time, you can also cross multiply. At the end of the day, you would still have to apply the rules of indices. So what we can do now in this question is we can cross multiply because it's easier to do that. So if you multiply 4 to the power of 2x by 1, it comes to 4 to the power of 2x equals 4 to the power of 3x plus 6, right, multiplied by 4 to the power of x minus 3. Now, looking at this question, 4 to the power of 2x equals 4 to the power of, since we have the same base, then we can add the exponents. Since the sign that's in between these exponents is x, I mean the exponential expression, the indices. So we add the exponents. So 4 to the power of 3x plus 6 plus x minus 3. Now if you collect like terms, 4 to the power of 2x equals 4 to the power of 3x plus 2 plus x equals 4x plus 6 minus 3, which is 3. Now remember that under exponential equations, we said that whenever you have equal bases, then the exponents also have to be the same. So according to that principle, 2x equals 4x plus 3. Now, since we are looking for x, we can take 4x to the left hand side of the equation, and then it becomes negative, or we can say that we can subtract both sides of the equation by 4x. So 2x minus 4x equals 3. 2x minus 4x is minus 2x, which equals 3. Dividing both sides by minus 2, we eventually have our final answer, which is x equals minus 3 divided by 2. And this is the same as 3 divided by minus 2 under fractions. So the correct option is option D. The next question reads, evaluate 27 to the power of 1 over 3 minus 8 to the power of 2 thirds divided by 16 to the power of 2 over 4 multiplied by 2. So let's write out this expression so that it looks neater. 27 to the power of 1 over 3 minus 8 to the power of 2 over 3 divided by 16 to the power of 2 over 4 multiplied by 2. Now this expression equals, let's take each number or each indices one after the other. So 27 to the power of 1 over 3 equals the cube root of 27. So let's write it as the cube root of 27 minus the cube root of 8 squared. This is cube root divided by the fourth root of 16, everything squared, multiplied by 2. Now the first one that we have is the cube root of 27, which equals 3. Multiplying 3 by itself 3 times gives you 27. That's what cube root entails. The cube root of 8 is 2. Multiplying 2 by itself 3 times gives you 8. So then that's 2 squared. So the answer that you have, the cube root squared, and the cube root that we have is 2. So 2 squared equals 4 divided by the fourth root of 16. Fourth root of 16 means a number that's multiplied by itself 4 times, and the result will be 16, and that number is 2. So then 2 squared, so the answer that you get here, you square it, you get 2 squared, which is 4 multiplied by 2. So then now we can say that 3 minus 4 is minus 1 divided by 4 multiplied by 2, which is 8. So the correct option is option C. Simplify 3 to the power of negative n minus 1 multiplied by 27 to the power of n plus 1 divided by 81 to the power of n. So 3n minus 1 3 to the power of n minus 1 multiplied by 27 to the power of n plus 1 divided by 81 to the power of n. So these numbers can be expressed in terms of 3 in powers. So 27 is 3 to the power of 3, 81 is 3 to the power of 4. So let's write it as 3 to the power of n minus 1 multiplied by 3 to the power of 3 bracket n plus 1 divided by 3 to the power of 4. Let us just prove that. So 27 multiplied by 3, 27 is already 3 to the power of 3. So multiplying it by 3 gives us 7 multiplied by 3 is 21, carry 2, 3 times 2 is 6, 6 plus 2 is 8, 81. So 3 to the power of 4 n. Now you can apply the rules of indices. So 3 to the power of n minus 1 multiplied by 3 to the power of 3n plus 1, right, divided by 3 to the power of 4n. Now if we apply the first rule, which is the product rule, or if you want to call it addition rule, we can now add these exponents since the bases are the same. So 3 to the power of n minus 1 plus 3n plus 1 divided by 3 to the power of 4n. Now this equals 3 to the power of n plus 3n is 4n, minus 1 plus 1 is 0. So then we have 3 to the power of 4n divided by, let me see if we are correct, because it seems I did something wrong. Let me just check or confirm. Yeah, sorry, I'm very sorry. So here it should have been, you see, 3 multiplied by n is 3n plus 3 multiplied by 1, which is 3. So here it should be 3, not 1. So this is where we had the mistake. So here it should be 3. So this is the same as 3 to the power of 4n. Minus 1 plus 3 is 2. So plus 2 divided by 3 to the power of 4n. Now we can apply this division rule. 3 to the power of 4n plus 2 minus 4n. So then at the end of the day, we end up with 3 to the power of 2, because 4n minus 4n equals 0. So now we have 3 to the power of 2, which equals 9. Now let's see. Yeah, so the correct option is option B. The next question on the screen reads, simplify open bracket 25 to the power of 2/3 divided by 25 to the power of 1/6, 1 over 6, close bracket, divided by 1 over 5 to the power of 7 over 6 divided by 1 over 5 to the power of 1 over 6, close bracket. So let's write it. 25 to the power of 2 divided by 3, all divided by 25 to the power of 1 over 6. This in brackets. This is divided by 1 over 5 to the power of 7 over 6. Yeah, I should have written as this way. So 1 over 5 to the power of 7 over 6, 1 over 5 to the power of 1 over 6. So now 25 and 25 are the bases and they're equal. This means that we can apply the division rule of indices. So 25 to the power of 2 divided by 3 minus 1 divided by 6. This in bracket divided by, we'll also then apply the second rule, which is the division rule on this expression, because 1 over 5 and 1 over 5 are the bases and they're the same. So 1 over 5, and then we subtract the indices, the exponents. So 7 divided by 6 minus 1 divided by 6. Now 25 to the power of, if you do the maths, these fractions, the common multiple, lowest common multiple is 6. 3 goes into 6 2 times. 2 multiplied by 2 is 4. minus 6 into 6 is 1. 1 multiplied by 1 is 1. So 4 minus 1 divided by 1 over 5 to the power of, now we already have a common multiple at the bottom, common denominator, so 6. We can now just subtract 7 minus 1 from 7. So 7 minus 1 is 6, which equals 1. So 25 to the power of 3 divided by 6 divided by 1 over 5, because 6 over 6 is 1, so 1 over 5. Now this will give us 25 to the power of 3 over 6 is the same as 25 to the power of 1 over 2, which is the same as the square root of 25, right? Divided by 1 over 5. So this leads us to 5 divided by 1 over 5. Now, to change this division sign, 5, you multiply, you change it to multiplication sign, and then you flip this fraction. So 5 multiplied by 5 over 1. So you turn it upside down. 1 goes down and 5 goes up. So we end up with 5 multiplied by 5, which equals 25. So the correct option is option A.